that a normal quadratic, if you're just graphing x squared, 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is negative 1, negative 2 squared is 4. That's what a normal quadratic looks like. When I look at this one, how was it translated? It went left or right? It went to the left. How many?
1.
And then it went down. 9. And so when you know those transformations, that gives you your vertex form. So we know then the vertex form, left and right is in the parentheses, and I told you if you add to x, you go to the left. So the vertex form is x plus 1 squared. Down 9 means it had a minus 9 on it. We have also seen that equation written in standard form. Now, we've never had to do this, but I just want to show you it's not two different equations. It's just what happens if you multiply this out. X plus 1 squared means I have that twice. So if you multiply those, you have to FOIL. X times x is x squared. 1 times x is x. 1 times x is x. 1 times 1 is 1. Like terms, we have x squared, positive x and positive x, plus 2x, positive 1 and negative 9 is negative 8. So you might have seen it written in standard form. When we had those, we would do the opposite of b over 2a to get our vertex. Okay, they're related. It's not two different things. It's just written two different ways. What we've done the past few days is worked on factored form. If you had this and you had to factor it, you would say, okay, what multiplies to negative 8 and adds to positive 2? What numbers would multiply to negative 8 and add to positive 2?
Negative 4. Positive 4, negative 2.
So in factored form, x plus 4 and x minus 2. Okay, all of these are the same quadratic. When I see x plus 4 and x plus 2, we talked about finding zeros. If you set x plus 4 equal to 0, you get negative 4. When I look at my graph, it hit the x-axis at negative 4. So I told you those solutions are where it hits the x-axis. If I set x minus 2 equal to 0, we get positive 2 because the original hit the x-axis at 2. You guys have to take an EOC in this class. There will be quadratics on that EOC, and it may be written in any of those forms. It might be a vertex form where you can think about transformations. It might be standard form, where everything's multiplied out and we have to do the opposite of b over 2a to get it. Or it might be factored form, where we know where it hits the x-axis. So all of those will show up. Any questions on that? I want to look at problem 3. And I want you to take a second and see if you can figure out what the vertex form. Normal quadratic starts at 0, 0. How was this one transformed? Did it go left or right? Went right, how many?
2.
And up or down? How many?
9.
Okay, so left and right is in the parentheses. If you add to x, it goes to the left, so right would be a minus 2. And then when it went down 9, so minus 9. Okay, I'm going to skip the standard form. I want to come over to the factored form. Look at where this graph hits the x-axis. If it hits -1. Do you know what would have to be in here? Plus. If you set x minus 1 equal to 0, you get positive 1. So to get -1, it's plus 1. Because we could get that from the x-intercept. Okay, it hit at 1, 2, 3, 4, 5. So the factor form is x minus 5. Now, we could also get that by multiplying the whole thing out to get factor. Just trying to show you some connections here. I want to look at problem 5. This time, I gave you the equation. And I'm asking you to draw the graph. Did I not copy the backside for you? Oops. Okay, you get to watch on this one. Then we're going to go back a couple pages in our notes and look at something else. So, where is the vertex on this one? You should be able to tell because it's in vertex form. What does a -1 do? Remember when I told you if we were finding the vertex, we would set that inside equal to 0, so you get +1. That's like moving right 1. If you plug a 1 in, you get 1 out, or you think about up 1. So this one has a vertex here. Can you tell me, does this open up or down? Down. How do we know that? Because it's a negative. Okay. Now, if we wanted more points, what have we done to get more points when we draw a graph? Yep, we usually make a table when we plug in points, so you could certainly do that. Just rough sketch, we know it would look something like this. If I asked you for the standard form, so you might be given something like that on the EOC, they just want to see if you can multiply this out. So x minus 1 squared means you have that twice. Keep the negative out here when we FOIL, so we get x squared minus x minus x plus 1. And there's still plus 1 on the end. What do you do if there's a negative on the outside? Yeah, it's like a -1, so we can distribute -1. So you get a -x squared plus x minus 1. And we still have that plus 1 on the end. So the standard form you might see is -x squared plus 2x. -1, +1 cancel. If I asked you to factor that, what would we do? What do they both have? X. You could take out an x. Okay, so your factor form might look like that. We are going to talk soon about using Desmos a little bit on these to help make those connections as well, because on the EOC, Desmos is allowed. So we'll be talking about other ways to help with that. What I want to do now, I want to go backwards in your notes. So, I want to go to this page. We did quadratic roots. And I want to look at, I think we didn't do problem number 4. So go back a few days. You're going to have a handout in a minute, and there's a couple of these that I wanted to review. Did everybody find that page? If I asked you to find this solution by graphing, so on our quiz Monday we're going to have a couple of these. We know on the graph the solution is where it hits the x-axis. If we are going to graph these, we always found the vertex first. How do we find the vertex? What was that formula we used? Over 2a. Remember, a is a number in front of x squared, so a is 1. B is a number in front of x, so b is negative 10. So the opposite of b, the opposite of negative 10 is positive 10 over 2 times a. A is 1. So we get 10 over 2, or 5. Where did we put that? In the middle. And then we did numbers smaller and bigger. You ladies check 2. You guys check 3. You two check 4. You two check 5. You two check 6. No, and Esther do 7. And I'll do 8. So everybody, remember we are taking our calculator, we are plugging these into the equation. So everybody better have a calculator right now. Twos, what'd you get? Threes. Fours. Fives. 6. 7. And I got 0. So then we can plot these. 2, 0. 3, negative 5. 4, negative 8. 5, negative 9. 6, negative 8. 7, negative 5. You can get your solution, that is a horrible looking graph, either by looking at the graph where it touches the x-axis or looking at the table. You're looking for x when y is equal to 0. So I can see from either the table or the graph those x's are 2. So my solutions are 2 and 8. The solution, when I ask for that, I'm just asking for the x value. So you're just telling me what x equals to make the y 0. Are there questions on that one? Okay, so what I want to do is give you a review handout right now. This is what our quiz will look like on Monday. There's 2 of them like this, where you have to do the opposite of b over 2a to get your vertex, make your table to get your graphs. The rest of them are factoring problems, like we've done the past 2 days, factoring and setting equal to 0.